plus k is equal to 0. And we have dealt with expressions like this in grade what? Is it grade 8, grade 9, somewhere there? Where we were looking at, those days we would look at expressions like x minus 1, x minus 2 is equal to 0. Then we'll say this is equal to 0 or that is equal to 0. You remember that? Yeah. So we are back there. Which means what? This is equal to 0 or this is equal to 0. Then you have a 0 or both. Having said that, this is a simple mathematical expression with a characteristic which is well known. Let's model it. It looks like this. That's y is equal to e lambda t. This point here is 1. Who can tell me about how this thing approaches the 0? Does it touch it? No. It doesn't, eh? This is an asymptote. So it gets closer and closer and closer without getting there. Which means e to the power lambda t will never be equal to 0. But if we get a result as 0, then this definitely is always 0. So from there we can therefore say m plus k is equal to 0. Definitely. Because the other term will never be 0. So if we are going to have a 0, then this is always 0. That being the case, now we have to solve for lambda. What is this lambda? Because we want to find it and plug it there, then we have a solution. If we can find the lambda and plug it there, we have a solution. And for our solution, we know that ax squared plus bx plus c is equal to 0. Then we can say x is equal to minus b over 2a plus or minus root of b squared minus 4ac. All that over 2a. Or maybe if I just say everything minus b, like that. We are familiar with that? Yes. So using that, we can then say, we can rewrite, we can find lambda. Now because it's quadratic, that means we are going to look at two values. Lambda 1, 2, minus b, minus, we know b, ne? Minus m over 2, over 2m plus or minus 1 over 2m root of b squared minus 4ac. Hey.
C squared minus.
So I'm forgetting to substitute. This is c squared minus 4mk. Oh, yeah. We can rewrite this expression. And we can say minus c over 2m plus or minus. These are two ways of writing the same thing. C over 2m squared minus k over m. It becomes that if you take this in the bracket, when this comes in, it comes as what? 2m squared, because we are taking it into a square root. So it becomes c over 2m everything squared, because it's also squared. Then we have 2m squared here. The 2 squared becomes 4. 4 over 4, the 4 disappears. Then we have m over m squared. We have k over m. Are we together?
Yes.
Hey, I'll try to do it fast. Then This bracket here is the critical bracket. I mean, did I say bracket? This, we call it the radical, is the critical thing for analysis. Because it can give three different results. One, you can have this being bigger than that, then you have two, then you have a real value here. Added and subtracted from another real value, you get two real roots. Are we together? You can also have this C being equal to that, which means this whole thing becomes 0, which means you have two equal roots basing on this only, because you are saying this plus 0, this minus 0, so it remains that. That's the second one. And the third solution is when this is smaller than that, then you go into complex. Are we together?
Yes.
Right. Now, this critical part here, it determines the nature of damping. So, when this is equal to that, we say a system is critically damped, which means when C squared is equal to 4 km, the system is critically damped. And when a system is critically damped, the damping coefficient, we call it the critical damping coefficient, which means CC, the critical damping coefficient is 4 km, which becomes what? 2 root km, which you can write is 2 m omega n. Omega n is equal to k over m.